All right, all right, all right. How's everybody doing out there in YouTube land? Peace in, YouTube. I just doing a take two on this. So this is part two of the grade 7 hardest math problems. And hi, I'm Greg from Greg's Tutoring NYC. I'm a tutor in the New York City area, obviously. And I'm doing a little series here about some of the hardest math problems. I've done grade 3, grade 4, grade 5, grade 6. Now I'm on part 2 of grade 7. I'm sourcing these from the New York State exams, okay? And they are the problems that most kids got wrong the most. So, given so many kids take the exam, it's pretty much a given that at least across New York State, that this is indeed some of the hardest math problems. They're hard for different reasons. Sometimes it could be the actual math itself, following steps. It could be concepts. It could also be the way the questions are worded and things like that. All right. So, so that's really where we're going to go here. My goal is not to focus on the actual raw problems. Obviously, we're going to solve them, so we need to do that. But the goal here is to approach things conceptually and with the topics in mind, so that when we come to a new problem, or you do, that you kind of have a virtual cognitive toolkit already able to move forward with, to be able to do that. All right. Just to make sure we're live here, because I'm getting a message popping up. That you kind of have a. Okay, I guess we're live. YouTube pops up a lot of different weird messages sometimes, so it's not always clear if we're good or not. So that's the perspective I'm going to take. A lot of you know who I am. I do a lot of tutoring for standardized tests, so that's kind of my incentive to do this, because this either becomes prerequisite material or even requisite material, depending on which test we're talking about. I normally help a lot of kids with specialized high school or just high school entrance exams. So it could be the Catholic high school entrance, New York City specialized high schools. There's a whole bunch of schools that have like mini tests that that you need to take, and it normally deals with math, ELA, and writing. Okay, so at this point we're just focusing on the math aspects. So I figured, I also tutor kids on taking the New York State standardized test, and I noticed certain patterns develop over years. So what I did was I looked through about the past 10 years of New York State test and picked out what it was saying the hardest problems were. It gives percentages and stuff like that. So I just picked the ones where most kids were getting wrong, the top X% or whatever. So what it means is this is an assortment. There's going to be some problems that you do know how to do, and just in general, on average, most kids got this wrong. So when I'm talking about majority, I'm saying like 70% of all kids got some of these questions wrong. So if you're really proficient, you went to a good middle school, you have your own tutor, whatever the case is, some of these questions may not necessarily be hard, but some are going to be. All right. So with that in mind, let's just try to jump right in here. So let me get rid of this main thing here. Here's the first question. Let me try to get that a little more centered so that we're not cutting off any part of it. Okay, that should be good. Let me just make sure it's lined up right. So before we kind of get into the actual raw problems, two things to make note of. First of all, give me 1 second because I'm going to write on the screen. So first of all, it says calculators allowed. Okay, so a lot of the things you guys are doing, you're not allowed to use calculators. So at least on this part of the New York State test, you're allowed to do it. Some of you might be taking the SHSAT or whatever. You're not allowed to use a calculator at all. If you're taking the PSAT, there may or may not be sections where you're allowed to do it. So if I pop up a calculator, that's where it's coming from. But remember, Your context might be different than the context of this. Okay, so in your case, you may not be allowed to use calculators. So be careful when I end up using them or not. It also turns out to be the case that even when calculators are allowed, it may not be your best choice to use them, right? Let me say that again. Even if a calculator is allowed, it may not be in your best choice, interest, benefit, score to actually use it. Because even personally, when I use a calculator, I make a lot of mistakes typing stuff into it, right? So don't depend on the calculator as this piece of magic or this panacea. It's not the case. Also, what I want to do is, as we analyze these problems, and again, I don't want to focus on the raw questions. I want to focus on numeracy and actually learning how to solve and think mathematically about stuff, so that sometimes we can do the answer without necessarily doing all the computations. Okay? And by the way, that's an underlying thing as well. A lot of these kind of tests and these kind of questions, they're arithmetic based. Okay? This question 29 is about geometry, but underneath it, once you know the formula, you're cool. So on that note, that's the second thing I want to point out, which is that if you look at the actual question, it says, what is the radius in centimeters of a circle that has a circumference of 16 pi centimeters? So this is really a circumference question. If you don't know how to do the circumference, you're done with. You can't solve this question. You can't even really make an educated guess, right? So that's not good. That's not good at all, right? So so you need to know your formulas. So just to give a context here, okay, when you take the grade 7 New York State math test, in the beginning, they give you this reference sheet. Okay, so the top is basically unit conversions, and underneath it is a bunch of formulas. Okay, both of these are limited, and the truth of the matter is you should know how to do all this and know all about all these conversions and formulas before going into the test. Okay, normally you kind of need this if you start to panic and stuff like that, but there's other skills you need to learn to address that as well. So in any way, if we look at the formulas, most of them are about area. They have the area of a triangle, the area of a parallelogram, the area of a circle. And the circle has two lines. One is there is the circumference. That's what this question is about. And then there's one about general prisms, okay, which is 8 times the height. So and it's incomplete. In other words, it doesn't tell you about the area of a square, the area of a rectangle. It doesn't talk about perimeter. So that's why I say this isn't really terribly helpful. You still really need to know all these, okay? It's kind of giving you a hint, especially if you take practice tests beforehand, that you kind of need to know the area of a triangle. So in grade 7, right, we're talking about basically the end of grade 7 here, you need to know all your area formulas, all your perimeter formulas, or your angle kind of things. You need to know a lot of stuff about basic triangles and basic shapes. So you should know really all about your 2D shapes and a lot about your 3D shapes even, right? It's talking about the last ones pertaining to volume. So you should start knowing about some of those things. And by the way, the grade 8 reference sheet is slightly different. When we get to grade 8, I'll show you that. But it's really just as simple as this. And look, if you're doing grade 7 material, you know your teacher talked about these things. So you should know that you need to know them, all right? If you're kind of not sure, hit me and send me up an email, GregsTutoringNYC at gmail.com, and I can send you that. On that note, don't forget to like, subscribe, and set your notifications for this channel. I do a lot of content. I do it in batches. I haven't done it in a couple of weeks now, but I'm probably going to start up again, especially since school started. So that's what you want to do. And YouTube's algorithm checks all that. So please smash the like button, guys. This takes me a lot of work and energy. It actually costs me money to do this. So, don't hesitate to do that. In fact, if you go to GregsTutoringNYC.com/gift, send me a tip or something, guys. This is not, this takes a lot of work, and I'm doing this for free. So that's the kind of thing. So in any event, at least just like and subscribe and set your notifications. So as I do more of these, I also do ones live streams a lot about the SHSAT, a lot about the ISEE, the SSAT, and so on and so on. Have a look at my channel. You can see that at GregsTutoringNYC.com/YouTube in lowercase. All right. So if you can do that. So let's finally just jump into this guy. So we can see that the formula was C equals, it was pi d, and it was also 2 pi r. Okay, and they're telling us, they're asking us what is the radius, and they're saying the circumference is 16 pi. So we can just do that. Right? We're going to divide both sides by pi. We're going to divide both sides by 2, and that becomes 8. So the only thing left over here is r equals 8, and that's a. Okay? And we had to do no unit conversions. This was centimeters, and this was centimeters. And by the way, before, let me bring that grade 7 thing back. You guys should know every single thing in here. Miles doesn't come up often, and when they do on a lot of these kind of exams, they actually tell you 1 mile equals 5280 feet. Okay? But the whole left-hand side you should know, and you should know a kilometer. You don't need to really know kilometers to miles. They'll normally tell you that. But you should know all your metric conversions back and forth. You should pretty much know a mile is 5280, even though they'll tell you. You should know a ton is 2,000 pounds, although they normally tell you that as well. Okay? You should know an inch to a yard to a foot, those kind of things. See, that's not on here, but you should know those. All right? So again, if you're kind of aloof or not clear really what the things you should know are, at least for grade 7, and for some of the other exams, okay, you need to kind of get a hold of that. Okay, you should know what all those things are, and there's a lot of them. It could be 50 to 100 of them that you kind of need to know at this point. All right. So again, I'm going to go for about a half an hour here, maybe, because we're already in for 15 minutes or whatever, and just go for there. Okay, so the next question I actually solved in part 1 of this stream, so we're not going to solve that a second time. I have, for some reason, had skipped that, so I don't know why. And again, if you guys, whoever's there, if you have any questions, please go for it. Give me 1 second, because it's showing there's a few viewers again. You guys can keep quiet if you want, but I like the stream to be interactive. Oops, sorry, I had that covering there. So if you guys have questions, please go and ask me. Okay, so what I like to do with a word problem is take a sentence at a time. And then within each sentence, if there's kind of subparts, normally separated by commas, I will look at those, and then I will build up phrases and sentences as we go along. And as we go along in the questions, I will try to build up my knowledge of it. I'm going to orate it, but if I'm solving this problem quietly, like if it was on an actual test, I would do it the same way. Okay? So this might take 3 minutes to explain as I go through each problem, but when you're doing it live in your head, it takes mere seconds. Okay? And then what I do is at the end of basically each sentence, I will ask myself questions about it so that I have some context to work with. And then I build up my understanding, and often I'm able to almost know what the question is going to be by the time I get to the end of it. And I'm trying to build up my understanding of what's going on. So Travis, Jessica, and Robin are collecting donations for the school band. Cool. They're collecting money. Travis wants to collect 20% more than Jessica. So like I said, I'm going to stop right there. So Travis wants to collect 1.2 of Jessica. Okay, where did I get that from? Well, if he wants to collect 20% more than Jessica, Jessica is 100% of herself. Okay? So if he wants to collect 20% more, he's going to collect 120%. Okay, let me drag this down because I'm not sure if it's actually showing on the screen. 120%. Okay, percent means division by 100. So 120 with this little symbol here means 120 over 100. And that, if we get rid of these two zeros, we get 12 over 10, and that's equal to 1.2. So that's where I got that from. So if we map Travis wants to collect 20% more than Jessica, that's what it is as an equation. Okay, Travis is, that's equal 1.2 of Jessica. Okay, Robin wants to collect 35% more than Travis. So Robin, again, it's 35% more, is 1.35 of Travis. If the students meet their goal and Travis collects $43, so we also know Travis is also $43. Okay, how much money did they collect in all? So there's a couple levels of this problem here going on. We have to kind of understand this algebraically, do some computations, and then finally answer the last question, which is how much did they collect in all? So once we find out what Travis made, what Jessica made, and what Robin made, we have to tally the three of those together. Okay? And the answers are all close enough to each other that we can't really make any other kind of a guess here. So that kind of creates a slight problem. So we know Travis is 43, and we know Travis is also 1.2 of Jessica. So what we're going to do basically is ignore this here. And just work off of 43 equals 1.2 of Jessica. So that means 43 divided by 12, because we're going to divide both sides by 12. That's going to end up equal to Jessica, right? So if we do that, I'm going to bring the calculator on the screen. Okay, we get 3.5833333333. So this is dollars and cents. So we don't know necessarily exactly what to do with that yet. Okay, we're going to put the bar over it because we're not really quite sure where to go with it, right? So now we also know that Robin is 1.35 of the 43. So we can get that as well. And we get 44 point 44.35. And those are our three numbers. So if we add those up, we're going to end up getting C. All right? By the way, we kind of have a heads up because Travis was 43.00. We know we had a 5 here and a 3 there. That's the only answer with an 8 in the ones column there. All right? And again, this is a problem. You're allowed to use calculators. This would be kind of too busy on a lot of exams to actually do, 1.35 times 4.3 and so on or whatever. So there's kind of issues like that. Okay, the next question is actually a doozy of a question. So we may actually spend a lot of time on this and just see where we can dwell. So the mean radius of the Earth is this much. So we're going to stop there. So we're going to get the radius of Earth is the 6371. And the mean radius of the moon is the 1735. Okay, so now we're here. And by mean, it means the average temperature. So the Earth is not an actual sphere. It's not perfectly round, if you will. It's the same for the moon. So what is the approximate difference? So they don't want an exact number necessarily. In the mean circumferences. So the average circumferences. So we're going to use what we did before, which is the C equals 2 pi r. For both of these. Right, so since it says calculate aloud, you could do that. And when you multiply it out for the Earth, I did this before because this is actually a long problem. You get 29 0 9 8 3 8. I don't know why my digits are coming out so weird here. 29098. That's 78. Is that correct? No, .38. And if you do the same thing for the moon with the 1737.5, you get 10 911.5. Okay, so it says the difference. So what we need to do is subtract the 29098.38 minus the 10911.5. So when you do that subtraction, do I have that on here anywhere? Oh wait, sorry, I did the wrong numbers. This was actually the subtraction answer. That's the answer. So that's how we end up getting B. This was actually equal to 40,000 and 9.88. Okay, so it says approximate. Now I use 3.14 in my computation, and that's why I'm slightly off. If you're using a calculator like a scientific calculator, because you notice the one on the screen, it only has plus minus divided. It actually doesn't show pi there. So I just used 3.14. And these answers were further enough away from each other that we can pretty much be good that the answer really is B. All right. So there's other ways to have solved this. One way was to notice that instead of computing the 40,000 and the 10,000, whatever, we could have used the formula as 2 pi, since it's 2 pi r. What we could have done was subtracted the radius of Earth minus the radius of the moon. Okay, and we still would have ended up with the same answer. Okay? And not only could we actually do the raw computations, but we could actually kind of do that in our heads to kind of guess the answer, because this is something you want to do in a lot of these cases. It's make an estimate of what the answer might be. Okay, so if we take the 6,000 here and this kind of 1,700 here, depending on actually how you want to subtract it or not, you can get 4,500 to 5,000. All right, 4,500 to 5,000. So we could double that, right? 4,500 times 5,000 is either 9,000 or 10,000. So we're going to have 9 to 10,000. And if we multiply it by 3, which is basically I pi, we notice we get 27,000 to 30,000. And the only one that's within that range is B. So that's cool, right? We could have also merged the 2 and the pi, because 3.14 gives you like 6 1/4. So you get about 6.25. So if we notice this was about 5,000, again, the only one, and it's lower than 5,000. So we know the answer is going to be less than 30,000. So again, B is really our choice there. So what we did is we actually computed it raw. We did kind of a shorthand, which is subtraction of the two numbers there, so that we're not getting too involved, even though we can use a calculator. But let's say calculators were disallowed. Subtracting the two radiuses probably saves you a little bit of time, so that way you don't need to do the 2 pi on those two kind of weird, ugly numbers. Okay, and then the estimate works as well. In fact, the estimate works perfectly. If the answer choices were close, like the answer B, and it also gave like 31,000 or 28,000, then you would actually have to do the actual raw computations. But in this case, we can make the estimate and actually get the right answer with no real hesitation whatsoever that, oh, we could have been wrong. This is pretty clear cut. Okay. Okay, so that was 37. Okay, a dealer paid 10K for a boat at an auction. Okay, cool. So again, you're asking yourself questions. What did the dealer do? The dealer bought a boat, or at least paid for it, right? What happened? There was an auction. A boat was purchased for $10,000. At the dealership, a salesperson sold the boat for 30% more than the auction price. So we're talking about 30% more of 10,000. With 30% of 10,000, right? If we actually wrote it out, if we do it times 10,000, okay, we can get rid of these two zeros, get rid of these two zeros, and we have 30 times 100, right? And we also, so that's 3,000. Makes sense. 30% is about a third. 3,000 is about a third, right? We could also approach these, especially on a lot of these tests. If you notice, the 30 is just a cool number. It's a multiple of 10. So 10% of 10,000 is 1,000. So 3 times that is 3,000. So there's multiple ways to kind of get this as well. The salesperson received the commission of 25% of the difference between the auction price and the dealership price. Okay, so what are the two prices? they're 13,000. And 10,000. Okay, the difference again is the 3,000. Right? So they receive the commission on 2,500 of that. Sorry, 25% of that. So 25% is 25 over 100. So the solution to this is not to multiply the 3,000 by 25. Okay, this is the same as a quarter. So it means division by 4. So if we take the 3,000 and divide it by 2, we get 1,500. And if we divided it by 2 a second time, because 4 is the same as 2 times 2, we get 750. And that turns out to be the answer. Okay? So this is really a word problem. I'm trying to use percents. There's 2% involving there, and to really just understand what's going where. The ultimate question is kind of a doozy because we have to get to 2 prices. Understand that this word difference means subtraction, and then build up from there. All right? So again, these are problems that end up getting tricky. And if you were asked the certain parts of it, like if you were asked directly what's 30% of 10,000, you could probably get that right. If you were asked what's 25% of 3,000, you would probably get that right. But when it's all piled together like this, it can start getting confusing. So that's why, and by the way, this little line I draw here at the end of each kind of thing that as I break it down, I actually do that when I'm actually solving these problems. So that I'm taking it a piece at a time, and just trying to make sense of it as I go along, and not only just up to the comma or the period. As I build up, I make super understanding, right? So we're taking each phrase and sentence in isolation, but we're also taking everything together up until what we know about it. All right. So that's kind of key here. By the way, here's one where it says calculate is allowed, and this is an example where you kind of really don't need it. Okay, and again, since it's easy to mistype on your calculator and so on, it's easy to get the wrong answer. All right. I find it interesting that they didn't have a choice here that was 3750, because some of you would take the 750 and add it back to the 3,000. Okay. In fact, some of you may choose C, just figuring like I don't know how to really pick it, but that's the closest answer. You kind of want to do better than that. All right. Okay, let me just make sure YouTube says we're still okay. It seems to. Okay, this is one that kind of throws you guys for a loop, because you're not used to the symbolicness of what's happening here, right? So they're just asking, what can I pull out of 32M and 56MP to make basically the distributor property, because that's the form of every choice here, right? So enough of you would probably think the answer was 8, because the greatest common factor of 32 and 56 would be the 8. So if we did the GCF of 32 and 56, we get the 8. Well, the problem with that, it turns out that all the choices have that, right? And 8 times 4 is 32M, and 8 times 7 is 56P. So do you see that's the problem with A? That if we actually do the distributor property here, we get 32M plus 56P. But this had an M in it as well. In fact, this had an M too, so what we need to do is spin the 8M out. Because 8M times 4 is 32M, and 8M times 7P is 56 MP, and that turns out to be the actual thing in the first place. So this turns out to be a question where there's really not many words to it. It's not really a word problem, but it's about your understanding what algebra really is. So in many GCF and LCM cases, you guys are being asked to do the the spin-off, getting the greatest common factor, the least common multiple, all this kind of stuff with a number. But here we're doing it symbolically. So be careful with that. And this is why it becomes hard, because this often doesn't happen in your classroom where you're being asked to kind of do that stuff. So that's what makes some of these questions challenging. And especially for some of you taking more involved standardized tests. So there's a disconnect that happens, that the classroom doesn't really reflect even the New York State tests, and vice versa, obviously. So that's a big gotcha. It's a big gotcha for a few reasons. First of all, some of the schools don't complete the curriculum or the standard. So by the end of your grade, there's still topics left over. Okay, and what some teachers do is, because they're required to cover them, is they kind of do a fast forward kind of bunch of topics at the end of the year, saying like you'll cover them next year, right? It could be anything. It could be factorization, prime factorization, finding multiples. In the case of question number 39, there's stuff like that. And then there's really what this is about, because the New York State test mainly tests you on your knowledge and what you memorize, and a lot of rote stuff. So that's what makes questions like some of these hard, which is these kind of branch off, and they're almost outlier questions. Okay. The second thing that happens on standardized tests is it takes that even a step further. Okay, it's not even asking you kind of this stuff. It's really getting down to you. Do you know your numeracy? Are you proficient? Have you mastered this thing completely? So that this kind of question, it's just second nature to you. It's obvious, like exactly what they're asking. Okay, and that's the deal here. So the classroom is a disconnect to even the state tests. And by the way, I use New York here because that's where I'm from, but this applies to any grade 7 class in the whole country for the most part, unless you're in an honors class or something like that. So we're talking about base level, right? But a standardized test is testing you on solving problems in novel situations and doing other kind of critical thinking that a test like this is not necessarily going to ask you. Doesn't mean these questions are not appropriate for those kind of things, especially since these are the harder problems. But that's the disconnect that's going on here. All right. All right. So we might do one or two more problems and call it a day. In fact, I might even do some of these further later on today, because I have to kind of reset myself now that you guys are back in school. To figure out some of that, because I have students as well. Everybody wants the same time. Okay, so Amber detected that this expression here, that kind of looks ugly, right, is equivalent to this expression. Okay, which statement describes the process Amber could have used to make that determination, is what they're asking you here. All right, so, what's going on here? So it really means you need to know how to take this, I'm going to call this expression A, and know how to convert it into B, which I'm going to put on top of each one of those. In fact, I'm going to lower this down because I don't know if you guys can see that on the screen. Right? So the way to do this is to actually kind of write it out in longhand, because we're going to try to use what we know, and I cover this multiple times in part 1. So we have 1/2 divided by, minus half, sorry, divided by minus 41 over 15. Okay, and we talked about that in these cases we need to take this here and convert this into multiplication by its reciprocal. Okay, and we can see now we have minus 1 times minus 15, and that's positive 15. And at that point, the minus sign is gone if we wanted to. But we also have 2 times 41, and that's 82. So we can just use the numbers and then add in the minus signs here. So minus times the minus is a positive, right? So we're going to get plus there. So that's equal to what they had there. So that's what we did. So that's what we did there, right? Let me get rid of this so it's because it's blocking the answers. So which of these is going to map that process? Okay, she divided a half by 15. No, she ended up multiplying 15 because 15 is the numerator here. So it's not A. Okay, she multiplied minus a half by minus 15. Yes, that's what you did. Right, because if we look at this is a half. Let's ignore the minus sign for a second. Well, let me put it in. Just we have a half times minus 15 over 41. Right? But this here is the same as the numerator over 1. So we get basically minus 15 over 1 times 1 over 41. Okay? That red is equal to this red here. So it says she multiplied a half by 15, right? So that means she did this times that, because 15 is the same as minus 15 over 1. And then she divided the result by 41. That's what this means. We're going to take whatever this result is here and multiply it by 1 over 41, which is the same as division by 41. So that means the answer is B. And let's just double check. She divided, so this up until here, we have the same as that, but then it says multiply the result by 41. And we can see that it's 1 over 41, so it's not C. And then she multiplied 1/2 by 15, right? Actually, I just said multiplied here. This was also divided, so that's wrong as well. And she multiplied minus half by 15, yes, and then multiply the result by minus 1, because that's what I just described in C. So in both cases, it's no good. So B kind of wins the prize here for this. By the way, this is an example where it says calculators allowed, and kind of that has nothing to do with this problem. Like, there's really no usage to use. And most of you, if you would actually enter this into your calculator, most of you would probably do it incorrectly. All right? Most of you would probably do minus a half. In fact, some of you wouldn't even be able to figure out how to do that. Anyway, once you got minus a half, you would divide it by 41, and then divide it by 15 or something like that. That's not what's going on. So you want these two boxed. This red box area here is really what it's going to turn out to be about. So this is an inequality because it says the least number of deliveries. Right? So Ben earns $9 per hour. So that's cool. Right? I'm putting my little blockage thing here. And so I'm going to just put a plus sign here. That doesn't necessarily mean addition. $6 for each delivery he makes. So let me think about this. If he works an hour and he makes 1 delivery, he made $15. If he works an hour and he makes 2 delivery, he does 9 plus 12. Okay? If he works 2 hours and he only makes 1 delivery, he's made $18 plus 6. If he works 2 hours and he makes no deliveries, he only made $18. Okay? But if he makes a delivery, he has to work some hourage. Right? He wants to earn more than $155 in an 8-hour workday. Okay? So we can figure out that he's talking about he wants to work 9 times 8, right? If he works 8 hours, then he's made $72. Okay? What is the least number of deliveries he has to make? So what we want to do is take that off of the 155. So we get 3, 8. Okay, so what we want to do is divide the 6 into the 83. Because that's how much money is left over that he kind of wants to make more than that of. So 6 goes into 8 once with 2 left over. Okay, and it's almost wants to get 6 times 4, but it's 3. And we notice we get a remainder, so we get 13.x. So if he makes 13 deliveries, he actually hasn't gone over the $83, which means he hasn't gone over the $155 either. So he has to do 14 to actually oblige where he does at least the number of deliveries to reach the goal. Right? He wants to make over $155, not 155 or less. Okay? And we can write that out. We could have solved this as an inequality that, 9 times the number of hours plus 6 times the number of deliveries. Depending on how we want to look at this, he wants to go greater than the 155. Okay, they tell us h, so we get 9h, or 9 times 8. Okay, that gets replaced by that, and that becomes 72. Okay, we do the same thing. We subtract 72 from both sides, so this becomes minus 72. That gives us back our 83. So we have 6d is greater than the 83, right? We do the division, and we end up that d has to be greater than the 13.x. So they want an integer, because this number, you don't do a half of delivery. It would end up to being the 14 again, all right? All right, let me do 1 or 2 more problems here. So this comes up often where they give you mixed fractions that you kind of have to deal with. And the calculator thing is the annoying part again, that sometimes the calculator is not going to help you. It might, because you might realize this is 17.75, right? Because 3/4 is the same as 0.75. But the 7/12 kind of gets you there. And what you kind of have to do is 7 divided by 12, whatever that answer is, add 8 to it. In the meantime, you're probably doing something with the other calculation, unless you know how to use the storage mechanism on your calculator where you do the memory plus and all this kind of stuff. It can get messy. So let's actually see what's going on here. A pile of newspapers in the class was 17 3/4 inches high. So let's draw that. We're going to stop here and visualize it. We can actually visualize it by doing it. Okay, so it's 17 3/4. Okay, that's newspapers. Each consecutive week for the next 5 weeks, the height of the, so something's happening for 5 weeks, the height of the newspapers will increase by 8 2/7. So they're going to be 5, 1, 2, 3, 4, 5. So each little height in here, use a different color here. Each little green height here is the 8.712. Right? So what is the height of the pile after 3 weeks? So after 3 weeks is right here. All right, so what we need to do is take the 17 3/4 and add to that 8 7/12 times 3. Okay, so if I notice the answer choices, 2 are like close to 26 and 2 are close to 42 and a half. So there's a divide there. Okay, what I'm guessing is that if we do 8 times 3, we get 24, and that. So I think A and B is only pertaining to what the green adds up to. But it says, what is the height of the whole pile? Okay, so A and B can't be my choices. So if nothing else, I've got 50-50 now. Again, this is your numeracy, and what you're trying to do is figure out how to use this in some sort of context that's going to help you answer the question. So these two are close enough that they're actually now going to force us to actually do that. So we're going to have to do that. So 8 times 3 is 24. And 7/12 times 3 gives me 21/12. This is a top-heavy fraction, so that's equal to 1, right? If it was 2, it would be 24. So we know we have down here is 12, and we get what, 9? Okay. We don't know whether to simplify this, but we're going to add it to the 17 3/4. So why don't we simplify it? So that's equal to 1. And we get 3/4 there too. Okay. We already know that we're going to now add up the 3 choices here, which is the 17 3/4, the 24, and the 1 3/4. We already know that 3/4 plus 3/4 is 1.5. So if we did everything right, the answer must be D. Okay, but let's just be sure. So 17, we have 24 plus the 1 here is 25. So we have to do is 17 plus the 25. So we get 2, 1. Yep, we get 40, 42, right? And we end up with adding the 1 back in. And we get choice D. All right, so you got to be careful with this stuff, that you're getting the right information and so on. Let me just double check here. Something's not adding up in my mind. So 7 times 3 is 21/12. 12, 19, 20, 21. That's 1 3/4. 17. I made a mistake somewhere here. Let's see. I'm getting 42.5, not 43.5. Yeah, I'm not seeing it. Oh, yeah, this is 24. All right, I'll make notes in the comments about that. Actually, let's make this the last problem we do. So again, I'm Greg from GregsTutoringNYC at gmail.com. Please like, please subscribe, and we'll do the part 3 at some other time. All right, guys. Peace out.